Okay, suppose it could be any of this. So I'm going to get a question that is like this. So the mean of the central limit theorem is the same as the mean of the original data, whether the original data is skewed left, skewed right, or normally distributed. That is what is the law of large numbers. The central limit theorems are mixed together. Okay, and the standard error, remember that this is standard error. The standard error of means is equal to standard deviation for population over square root of sample size. And in this question, they gave me standard deviation of 14 and sample size of 32. If I solve this, I'll get the standard error. All right, so that's what they're asking me. So what is the standard error? You calculate this. Remember, you have to calculate it and leave it to 3 decimal places. The mean is still the mean, except that it's called mu x bar. The only difference is the mean is equal to the mean, but standard error, which is the same as standard deviation of distribution of means. Distribution of means is the same as central limit theorem. Okay, so the standard error is 14 over square root of 32. You find that answer to 3 decimal places and put it there. We need to go up so I can see that question that asked about when it is skewed right. So let me see. Let's see what that question I'm looking for. Okay, attained from anomaly distributed. Okay, these questions are still very. Let me go to. I need to do an example of central limit theorem or distribution of means, so we can make sure that we. Unfortunately, this question is not clear, but I can read it. This says describe the sampling distribution of X bar, but this question says the simple random sample of n is equal to 36 obtained from a population that is skewed right. Everybody look, skewed right. I got to stand up and say this. When I said this question in exam last year, some people, when they see skewed right, they will say that is not enough information. I cannot use skewed, but central limit theorem says the data can be skewed right, skewed left, or normally distributed. The central limit theorem still applies. So skewed right does not matter. You still have to do the calculation. Is that clear? It's in the exam. This question is in the test already. But I just want to let you know when you see it, don't say you cannot do it because the data is skewed right. No, that's what central limit theorem says. Central limit theorem says it can be skewed right or skewed left from a normal distribution. Central limit theorem still holds. The distribution of means still holds. Okay, just that. Okay, so now I know I'm told to find what is the probability. Everybody look. What is the probability that X bar, a random variable, is greater than 85.75? Let me draw a normal curve. And if you allow me, I will draw a normal curve of central limit theorem. I usually draw this because they're asking you what is the probability that a random variable called X bar. So this question is on central limit theorem. And so I told you it's already in the exam. You cannot mistake it with ordinary normal distribution. Okay, so the mean of this normal distribution, I can see this mean. The mean is 84. What I cannot see is the standard deviation. I'm guessing it is 6. It is 6, hopefully 6. But anyway, that question is blurred out. But this is 80, that question is 85.1. Actually, the mean is 84. And 85.75 is on the right-hand side of the mean. So 85.75. So I'm asked to find the area from this random variable to the right. Why is it to the right? Because let's see, the question says greater than. Is that clear? And remember that to the right means to positive infinity. Positive infinity, 1e to the power 99, because my calculator does not understand infinity. Okay, so I'll write the argument again. The argument is normal CDF. So it is normal CDF, whether it is only ordinary normal or central limit theorem. It's normal CDF again, the same thing. But so the lower bound, upper bound, the mean, which mu x bar, if you are writing it, write it this way. Make sure you write it so that you know it. Mu x bar and standard error. Show that you understand what you're doing. Okay, now I will put in what I know. Okay, so what I know are the lower bound is 85.75. So 85.75. Upper bound is 1e to the power 99. The mu x bar is 84, the same thing as the original mean. The standard error, but let's write it here so that we can make sure we remember. So the standard error is standard deviation. That standard deviation looks to me as if it is 6. So I will not put this question because I will just make sure I get a clear one. Over square root of sample size, square root of sample size is 36. 6 divided by 6 is 1. So the standard error is 1. So you put 1 here. So imagine that you put 6 here. Imagine that instead of putting 1 here, you put 6. Because it makes the difference. This is what makes the difference. The standard error for this question for 1. Is that clear? Is that clear? Because you're using the standard error. It is area on that central limit theorem. Is that clear? Okay. Okay. You don't clear this question. If you don't say you forgot. The only difference is that in central limit theorem, you will be using standard error. And it's not the same as standard deviation. Okay. Now let's calculate. So I'm going to get my calculator and calculate. And by the way, we don't even have to calculate this one because we're not sure what that. Let's get another question. Let me get another question on central limit theorem. And then you answer these questions here, but the one that is in your exam is clear. So let's get another one that is, before we get to hypothesis testing. I don't want to use all the time too. So there's another one that is clearer than that question. Okay. There's another question there that is clearer. Okay, not hypothesis testing. If I don't see it, I get it from the other class. Right. I'm looking for another one that is on critical values, central limit theorem. Okay, if it's not, I'll just pull up another one. This one is why didn't what is this one? Is Lord again. Oh, what must be true regarding the description in order to, let's see, 10. Is that okay if I go to get this from, is that okay if I get it from here? This is not your class, but it's the same scale because it's not your class, but it's the same scale. I'm going to pull this one up. This is clearer. All right, this is the same question. It's clearer. I'm going to pull this one up. It's not even your class, but I say you'll get the gist when we come over here. Okay. I know that I just pulled this one up, so it will not take it. So I'm going to reshare again. Okay, and I will get this, my calculator, and share. Okay, what I'm trying to say. A simple random sample of size n is 36. N equal to 36 is obtained from a population. This question is the one that is blurred in your question, but I want to make sure that you see. I want to make sure that you see that it's skewed right. This 120 is your class too, but it's another school. Final exam practice. I'm going to post your final exam practice tomorrow. It's ready. So final exam is the 12th? Yeah, your own class. Would you do early exams? Say it again. Would you do early? I don't do early exams unless you have already purchased a ticket to go to England. Yeah. So the only people I give early exam was have a ticket that I can see. You have the purchase ticket. Yeah. I want to see it. Sure. Okay, no, you have to. I don't know how you can email me and take important things out of it. You purchase a ticket, you are traveling out of the country or you're going to somewhere and you will not be around. So, but showing me alone is not enough. I need an evidence because I'm not allowed to give early final exams. I don't want to override the school. The school said my class will take the exam on the 12th. It's showing you that evidence. What I want you to email me an evidence, but don't show me your important numbers. You know what I mean by important numbers? So could I send you the confirmation? Confirmation, please make sure you just be careful without sending me that. I don't want your phone number there. I don't want your credit card number there. I don't want anything that is confidential, okay? So don't be in a hurry to send it to me. Just send it to me later. Then I will give you the exam sometime next week. Exam is ready. Okay? Do you understand? I cannot give you exam unless I have a document. I cannot go against the school rule. School rule says my class is taking exam on the 12th. Let's be here until that date. So we're gonna do. I'm giving exams already, and they're taking it online in the last school. So I won't see them again. I reviewed for them. I won't see them again. They finish the exam. They go home from today. But that's what the school says here. So we're going to be here. Do it here. Right. So this is 77. No. Can you check the final exam? It is T10. T10 have exam on the 7th. Okay, can you check that? And then let's go back to this. Look. You must be careful. It says, what is the probability that X bar? In other words, this question is a central limit theorem question. Is that correct? This is a central limit theorem question. And you must know that before you start. What is an X bar? Usually it was used to be X only when it is normal distribution. Now it's X bar, central limit theorem. Which means you'll be using new X bar standard error. So, we're given all other things. So let's go and do what we're supposed to do. Okay. So I'm going to draw a normal curve representing what I'm given. Okay. And let's see, recording this better. Post recording. Okay. Okay, so I am given that the mean of the original data is 73. By the way, the most important thing here is that the data is skewed right. The data is skewed right does not mean that the data, you cannot do inference. You can do inference according to central limit theorem. So the mean is 73. The standard deviation is 24. Therefore, standard error is 24 divided by square root of sample size. And that I can just write 6 here. 24 over 6. Therefore, standard error is equal to 4. I get that. Now, I am ready to find the area to the right. So normal CDF, the lower bound is here because I'm accumulating to the right. So 79.4. The upper bound is positive infinity. The mean is 73 because I'm given raw data. The standard error is 4. The standard error is 4. Is that clear? If you put 36, okay. If you put 24 there, it's as good as you didn't do that question because you failed it. And by the way, there are A, B, C, D. So you have to make sure you get it right. Because if you get that one right, you get all of them right or wrong. So if you miss it and use standard deviation, you miss it all. And if you know this, you actually know all the critical values for confidence interval hypothesis testing, because the standard error is used for confidence interval hypothesis testing. Okay, and now you get a calculator and calculate the area to the right. So second distribution, and I'm looking for area under the normal curve. And the lower bound is 79.4. So it is 79.4. The upper bound is 1/8 to the power 99. Remember, we have to find E. 99. The mean is 73. The standard deviation is standard error. Hello? Standard error. And it's 4. And I'm going to paste. So I find the area. That area is going to be a small area because it's area under the central limit theorem. And that area is a decimal 0.0548 in percent. 5.48%. All right. Besides standard error, all the things in normal distribution and central limit theorem are the same. That is the only difference. Okay, so we'll quickly go to confidence interval. Yes. Okay, so you can answer all this question. All these questions are in your test too. Okay, find what are the 2 requirements for discrete probability distribution. Oh, well, the own is final exam. So I'm going to take it because we're not doing probability in this. Okay, so this one right here is B. Hopefully my shell will still get it. Okay, so let's get a hypothesis test and do hypothesis testing question, and we want to do T, hypothesis testing. That way we have touched almost everything. Okay, determine the point estimate. Good question. Well, I just want to let you know that this question will be in the test. Determine the point estimate of the population mean and margin of error of the confidence interval. So you are given the lower bound and upper bound of a confidence interval. So let me draw a number line. So lower bound is 21, upper bound is 25. And this is population mean. So the point estimate is the mean, X bar, sample mean. Okay. And remember, there are so many ways you can find the margin of error, but I think one of the easiest ways is margin of error is equal to upper bound minus lower bound divided by 2. That is 25 minus 21, which is 4. 4 divided by 2 is 2. Therefore, margin of error is 2. So the margin of error, the point estimate is, and then they want me to find the point estimate. It is 25 plus 21 divided by 2. Point estimate X bar is 25 plus 21, and that gives me 46. 46 divided by 2 is 23. The margin of error is 2. Okay, so that's the question. It's not bad. It's not bad. Okay, let's go to practice question. Put the following critical values in order. I hope you know that this is T critical value, and T critical value is this degree of freedom. And when you are told that it has 8 degrees of freedom, then you know that sample size is 9. If this here sample size is 9, this here sample size is 19. So find the critical value. So I just get my calculator and do inverse T. So second verse, what is inverse T? And I am in number 4. And then area to the left, because we want to know, they didn't tell us the, we're just going to put in 0.02 because they didn't tell us whether it is two-tailed or one-tailed. Remember, if it is two-tailed, you divide by 2. One-tail right, you don't divide by anything. Degree of freedom here is given to us 8. Okay, and then I just paste. Okay, so the first one is negative 2.45. That is the critical value. For this one, we can also do that. I'll bring down second enter. That way I don't have to do it again. And then I would put 18 here. And I close parentheses. I hit enter. And this is negative 2.21. And then the Z value, which is not critical, it's not T. So inverse norm this time. Inverse norm. And the is 0.02. And everything is good. Okay, so you notice that in case of 8 degrees of freedom, notice that in 8 degrees of freedom, it has negative 2.44, 18 degrees of freedom, negative 2.21, which is smaller. Actually, this is larger. And the inverse norm is the largest. In other words, the T has larger degrees of freedom. The T's. before you do it, I'll just draw it. Make sure, because they're negative. You don't want to be confused. And remember that you have answers in this. Confidence hypothesis testing. Let's go and do hypothesis testing. Let's go and do hypothesis testing. A simple random sample of size n is drawn from the population as normally distributed. Sample mean is that. I'm talking about number 22. Okay, and the sample standard deviation is that. Construct a 95% confidence interval. So we're going to do one. We're just going to do one. We have everything given to us. Don't worry about doing it by hand. It's not necessary to calculate it by hand. So you can quickly go to your, remember you have sample size given to you, and it's a T confidence interval. How do you know that? It's a T confidence interval, but because they didn't give you the population standard deviation. They give you sample standard deviation. So I will go to my calculator quickly. And where do I see T confidence interval? So I go to Start, Test, T interval. T interval is right here. And I'm not given data, I'm given stats. And what is the X bar? X bar is 112. What is the standard? What is the standard deviation given to me? Standard deviation given to me is 10. What is the sample size given to me? What is the sample size in the first one? Sample size is 15. So you can go ahead and do your confidence level without, then what is the level of confidence? 95. I will calculate. So just make sure you are trying to finish the test. You can show your work as much as you can, but there are going to be about 15 questions. And make sure you finish the test, because some of them have A, B, C. Okay, so the lower bound is 106.46. The upper bound is that. You can be told to find the margin of error. Margin of error is upper bound minus lower bound divided by 2. And whatever you are told to find, you can find it. Then fill in the blank spaces. Okay. All right. I'm just going to get a hypothesis test so that we make sure we have done all of them. That was the hypothesis test we did the other day. Remember, there are 5 steps in hypothesis testing. You might want to remember the 5 steps. I can actually move up and look for that. There are 5 steps in hypothesis testing. And the question can ask you to start from calculate the p-value. By the way, let's answer this question. It looks easy, but let's answer it. Fill in the blank in the statement below. The procedure for constructing a confidence interval about a mean is robust. It's robust, which means that minor departure from normality do not affect the accuracy. That is why you can actually use skewed data to do confidence interval. It's robust because I can throw in a question like that so that you can make a good grade. Okay. Looking for hypothesis testing. And it's going to be a T hypothesis testing, by the way. Question is going to be a T hypothesis testing. Okay, let's see. Okay. Instead the population mean. Okay. No, an alternative hypothesis. Suppose p-value of this is this to explain what is your conclusion. We can actually do this, but I need a two-tailed hypothesis testing. Let's see if we can get a two-tailed hypothesis testing. Well, this is one tail. Well, we can do it. Anyway, to test HO, the mu is equal to 20 versus HI, mu is less than 20. What kind of test is number 6? What kind of test? Right tail, left tail? What kind of test is that? Look at what you are given. It's a left tail test. It's a left tail test. If X bar is 18.5 and standard deviation is 4.2, compute the test statistic. Remember what the test statistics is? By the way, we are using T distribution because they did not give us the population standard deviation. Therefore, the test statistic is T equal to X bar minus the mean all over. I hope you know that this is mu X bar, even though it doesn't make a lot of difference. Standard deviation over square root of sample size. All right, and then you plug in what you know, calculate the test statistics. So this is the third step in hypothesis testing, but they ask you to do that first. So it doesn't matter. You have to know the 5 steps in hypothesis testing because any question can come first though. All right, so X bar is given to us as 18.5. The mean is given to us, the status quo is given to us as 20 divided by the standard deviation is 4.2 divided by square root of sample size, and the sample size is 19. And you can calculate this. The most important thing is, do you know the formula to use? Do you know the formula to use? That's very, very important. Because if you're given the sample standard deviation, it's another way. You might not be told to use T distribution, but it's another way of telling you it's a T distribution question. You're given sample standard deviation. Then what kind of test are you doing? It is a T distribution hypothesis test. So suppose you are in a hurry and you want to put it in your calculator, or you must need to know that you're doing a T test. T test. So I'm going to go to my calculator and so I'm going to go to my calculator and go to stats, clear that, go to stats, and I'm doing a t-test because I don't have the population standard deviation. I have the sample standard deviation. So I'm doing a t-test, which is number 2, t-hypothesis testing. All right, I have the data. What is the status quo? What is the status quo? The mean we're talking about is 20. The X bar is 18.5, 18.5. And the standard deviation of that data is 4.2. That's sample. That's why we're doing T. And the sample size is 19. I'm saying that you could quickly start doing your hypothesis testing or confidence interval without doing a whole lot. Even if they start asking you from question number 5, one way or the other, all the details will be in the question. Is that clear? One way or the other. If somebody's trying to beat you up, if you know what to do, you can beat the person. You can start from the, you can start using all the data and go to your calculator. Calculate the hypothesis testing, and then the hypothesis testing will give you test statistics, give you the p-value, give you everything. Is that clear? The only people that will confuse are those who did not study. They will confuse if you didn't study. But if you can start, if you study and they start from question number 4, you go and do what you have to do and finish the test and make an A. Is that clear? Okay. All right. So I am going to do, they give me a left tail test. So I select left tail test. I told you I like to draw in hypothesis testing. So I'm going to draw. And by the way, looking at the question, the alpha, the probability of accepting the null hypothesis is, let's see what it, I think it's 5% somewhere. Okay, let's pull it up. So this probability right here is 6.8% or 6.9%. In other words, p-value, you see the p-value. The p-value is 6.9%. All right, so let me see what the alpha is. What is alpha? Looking for it. It should be in question number C. Question C. I will find it sooner. Oh my goodness, this is just unable to establish secure connection. What? All right. Okay, let me look for that. P-value is 0.05. So 6.9 is greater than 5%. Therefore, accept the null hypothesis because the p-value is greater than alpha. And even if you use the standard method, the T critical value or the test statistics will be in the acceptance region. So p-value has already accepted the null hypothesis. And therefore, you can say that the status quo still holds. You do not have enough evidence to reject the null hypothesis. The status quo still holds. You do not have enough evidence to reject the null. And then once you make that decision, you can also start answering other questions will follow, provided you know that p-value must be greater than alpha for you to accept the null. Is that clear? For you to accept the null, p-value must be greater than alpha. I think I have touched everything. I have touched everything that's going to be in the test. You just have to study. Some of these questions are repeats, so if you study one, some of them you know the other. Okay? Confidence interval, you already know that. Now the margin of error, calculate the confidence interval, find the margin of error, you should be able to find that. What I want to make sure that you remember is that you know the difference between, find the area under the central limit theorem and find the area under the normal curve. You must know them because they are different and they are all in the test. All right, any question? Test will be next class. I don't want more than 15 questions there. I think I'm going to reduce it to 13 actually, because there are ABC there. ABC. Any questions? All right. I'll see you on Thursday, test day. Tomorrow, the practice final exam will be in your box. You want me? Yeah, I'm sorry. There are some I didn't put. I'll post the video. Yes, let me actually stop it.